All right, hello everyone. Welcome to my channel. And this channel is all about educational uh, matters and mostly educational matters that are fairly obscure and esoteric, things that people don't really know anything about, um, but that are important to me. And I feel like they would be important to other people if they did know about them. So I try to bring them to light, mostly people who have spent their whole life working on something, wrote up their magnum opus, usually like a theory of everything, something that's all encompassing, um, and nobody's ever read it. And so I'm trying to, a lot of these people are my heroes. I'm trying to bring their work to light and to a certain extent to synthesize their work, because I think once you get to the theory of everything stage, um, all the theories of everything are ultimately the same. They just come out in different languages depending on your angle on it. You know, your different perspectives. Uh, I guess maybe kind of like a hologram or something, or at least an elephant in the old Indian parable. Uh, okay, now today we are looking at this is a 164th video that we've done on the reciprocal system of theory from Dewey B. Larson. And Mr. Larson was an engineer who wrote up his reciprocal system of theory, which is a theory of everything, a system of theory that allows us to take control of science, where we can figure out the science for ourselves, because he presents a simple, logical, and straightforward system to plug in to any subject, scientific or otherwise. But you have to really kind of understand the system and how it works before you can do that. Now, we are looking at his 1979 book called Nothing But Motion. And this book is mainly on physics, but it reflects the basic idea behind Larson's system, which is that we live in a universe of motion. The universe is not made out of matter, not made out of energy, but it is made out of motion. This is illustrated in the form of the Einstein's equation equals mc squared. E energy equals matter times the speed of light squared. If energy can be converted into matter and vice versa, that means that neither one of those things can possibly be the most fundamental thing in the universe. And actually, that the most fundamental thing is the c squared part, the speed of light squared. And so matter and energy are merely two different kinds of motion, as well as every other type of scientific phenomena you can think of: acceleration, force, pressure, electric charge, magnetic flux, um, you know, even matter, density, acceleration, um, capacitance, and many, many other quantities are all forms of motion. And what distinguishes Larson's uh, theory from other people who have decided that the universe is also made out of motion is that Larson defined motion as the relationship between space and time. This sets up a generalized reciprocal relationship between space and time. You can think of motion as a fraction, with either space or time as the numerator and either time or space as the denominator. And so that fraction gives you that kind of a reciprocal relationship. Um, all of those qualities, quantities, um, energy, matter, acceleration, so on, can be expressed exclusively through time and space. So, you know, in Larson's system, energy is time over space. Matter is time to the third power over space to the third power. Speed, we know, is space over time, 10 miles per hour. Acceleration is space over time to the second power, 9.88 meters per second squared. Capacitance turns out to be space to the third power over t, which actually kind of disagrees with Larson's own derivation of that, but that was, I would say, corrected by Dr. Bruce Perret in the last 25 years or so. Then, in addition to this reciprocal relationship between space and time, it basically means that what we have is that space and time both have their coordinate aspects. They both have 3 or more dimensions. They both have their clock aspects, which is a scalar motion, a motion that has a magnitude but no direction. And just like a clock, it's always going forward, but it's not going in any particular direction. And so that's clock time. It's always getting later and later and later. And in the same way, there is clock space. Things are always getting farther and farther and farther apart. And that is seen in the Hubble telescope. All of the distant galaxies are moving away from each other. And then we also have the discrete unit postulate, meaning that time and space only come in discrete units. There is no, there is a minimum unit of time and space. There's no continuity there. They come in chunks. Those chunks are very small, so it looks continuous, but it isn't. They look continuous, but they're not. And if you have 1 unit of space in 1 unit of time, 1 over 1, then you have the speed of light. And the speed of light is therefore the midpoint of the universe, not the maximum speed that Einstein claims it is. Einstein is missing an entire half of the universe that Larson calls the cosmic sector. This is where all the motion is faster than the speed of light. And in the material sector, that's the sector we're familiar with, where everything is slower than the speed of light. So that makes sense. If you have a universe of motion, you have what you have as the origin of that universe is already motion. You have motion before you have anything moving. You have motion. And that is what Larson calls the progression of the natural reference system, outward motion at the speed of light in all directions. And then he takes his measurements from that datum, that 0 point so the 0 point for Larson, where he takes measurements from, is the speed of light outward in all directions. Are we going faster than that or slower than that? If you're going, faster than that, we're talking about cosmic sector, and we're talking about time over space relationships. And if we're in the material sector, we're talking about space over time relationships, less than the speed of light. And so he kind of plugs that in. And so we're in chapter 8 here of the book, Nothing But Motion. And he was talking about how he was critiquing Einstein's theory of relativity and how the theory of relativity gives you the right answers because it is mathematically correct, but that the theory is not conceptually correct. It gives you the right answers, but it does not tell you why it gives you those right answers. It just tells you to shut up and plug in the equation and don't ask any more questions. And he presents quotes from Einstein where he's saying just that. He's saying, just plug it in and don't worry about what it actually means. And in some cases, like Werner Heisenberg says that it actually doesn't mean anything. Not only do you not have to worry about what it means, but it doesn't mean anything. So Larson, we're going to take over for let Larson talk here about that lack of scientific rigor in the theory of relativity. Okay, taking over here in chapter 8. Of course, this lack of a conceptual background is a general characteristic of the basic theories of present day physics. The free inventions of the human mind, as Einstein described them, and the theory of mass increase is not unusual in this respect. But the arbitrary character of the theory contrasts sharply with the full explanation provided by the reciprocal system. This new system of theory produces simple and logical answers for all questions, similar to those enumerated above, that arise in connection with the explanation that it supplies. Furthermore, one of these is, in any respect, ad hoc. All are derived entirely by deduction from the assumptions as to the nature of space and time that constitute the basic premises of the new theoretical system. Both the reciprocal system and Einstein's theory recognize that there is a limit of some kind at unit speed. Einstein says that this is a limit on the magnitude of the speed, because on the basis of his theory, the mass reaches infinity at unit speed, and it is impossible to accelerate an infinite mass. The reciprocal system, on the other hand, says that the limit is on the capability of the process. A speed in excess of unity cannot be produced by electromagnetic means. This does not preclude acceleration to higher speeds by other processes, such as the sudden release of large quantities of energy in explosive events. And according to this new theoretical viewpoint, there is no definite limit to speed magnitudes. Indeed, the general reciprocal relation between space and time requires that speeds in excess of unity be just as plentiful and cover just as wide a range in the universe as a whole as speeds less than unity. The apparent predominance of low-speed phenomena is merely a result of observing the universe from a location far over on the low-speed side of the neutral axis. Okay, so what he's this comes into play in a major way once we start talking about astronomy. He says that basically the speed of light can be crossed quite easily by a star or by a galaxy when they explode. So when they explode, that creates faster than the speed of light speed. And he'll get into that when we look at his book on astronomy that's called Universe of Motion, and also in his 1971 book that's called Quasars and Pulsars. I think that Universe of Motion book is from 1984. Okay, back to Larson. One of the reasons why Einstein's assertion as to the existence of limiting speed was so readily accepted is an alleged absence of any observational evidence of speeds in excess of that of light. Our new theoretical development indicates, however, that there is actually no lack of evidence. The difficulty is that the scientific community currently holds a mistaken belief as to the nature of the change of position that is produced by such a motion. We observe that a motion at a speed less than that of light causes a change of location in space, the rate of change varying with the speed or velocity if the motion is other than linear. It is currently taken for granted that a speed in excess of that of light would result in a still greater rate of change of spatial location. And the absence of any clearly authenticated evidence of such higher rates of location change is interpreted as proof of the existence of a speed limitation. But in a universe of motion, an increment of speed above unity, above the speed of light, does not cause a change of location in space. In such a universe, there is a complete symmetry between space and time. And since unit speed is the neutral level, The excess speed above unity causes a change of location in three-dimensional time rather than in three-dimensional space. So that is the key there. The chapter itself is called Motion in Time. That uh, gives you the idea, if you understand the reciprocal system, that he's talking about speeds in excess of that of the speed of light. Because if you have the speed of light as the midpoint, and you have the material sector over here, you have the cosmic sector over here, you the way that you relate the two is basically by inverting. You invert the roles of space and time. So over here, all the motion is in space, but over here, all of the motion is in time. And they both have their coordinate aspects. They both have three or more dimensions. And so we don't really know how to recognize motion faster than the speed of light. The scientists, the legacy scientists, are basically saying it doesn't exist. There is no motion faster than the speed of light. Larson is basically saying that, yes, there is motion faster than the speed of light, but you don't know how to look for it, and so you're not finding it. You have to look in terms of motion in time, not motion in space. And so he's going to kind of inform us what that looks like. Okay, back to Larson. From this, it can be seen that the search for tachyons, hypothetical particles that move with a spatial velocity greater than unity, will continue to be fruitless. Speeds above unity cannot be detected by measurements if the rate of change of coordinate positions is in space. We can detect them only by means of a direct speed measurement or by some collateral effects. There are many observable effects of the required nature, but their status as evidence of speeds greater than that of light is denied because present-day physicists on the ground, by present-day physicists on the ground, that it conflicts with Einstein's assumption of an increase in mass at high speeds. In other words, the observations are required to conform to the theory rather than requiring the theory to meet the standard test of science, conformity with observation and measurement. So once again, he's exposing the theory of relativity and really 20th century science in general as being utterly unscientific, and pretty much just bowing down to Einstein and saying, hey, if you make an assumption, then we follow that, in spite of the fact that we have actual evidence that, debunks your assumption. Okay, back to Larson. The current treatment of the abnormal redshifts of the quasars is a glaring example of this unscientific distortion of the observations to fit the theory. We have adequate grounds to conclude that these are Doppler shifts and are due to the speeds at which these objects are receding from the Earth. Until very recently, there was no problem in this connection. There was general agreement as to the nature of the redshifts and as to the existence of a linear relation between the redshift and the speed. This happy state of affairs was ended when quasars were found with redshifts exceeding 1. On the basis of the previously accepted theory, a 1.00 redshift indicates a recession speed equal to the speed of light. The newly discovered redshifts in the range above 1.00 therefore constitute a direct measurement of quasar motions at speeds greater than that of light. But the present day scientific community is unwilling to challenge Einstein, even on the basis of direct evidence. So the mathematics of the special theory of relativity have been invoked as a means of saving the speed limitation. No consideration seems to have been given to the fact that the situation to which the mathematical relations of special relativity apply does not exist in the case of the Doppler shift. As brought out in Chapter 7, and as Einstein has explained very clearly in his works, the Lorentz equations, which express those mathematics, are designed to reconcile the results of direct measurements of speed, as in the Michelson-Morley experiment, with the measured changes of coordinate position in a spatial reference system. As everyone, including Einstein, has recognized, it is the direct speed measurement that arrives at the correct numerical magnitude. Indeed, Einstein postulated the validity of the speed measurement as a basic principle of nature. Like the result of the Michelson-Morley experiment, the Doppler shift is a direct measurement, simply a counting operation, and it is not in any way connected with a measurement of spatial coordinates. Thus, there is no excuse for applying the relativity mathematics to the redshift measurements. Inasmuch as the time dilation aspect of the Lorentz equations is being applied to some other phenomena that do not seem to have any connection with spatial coordinates, it may be desirable to anticipate the subsequent development of theory to the extent of stating that the discussion in Chapter 15 will show that those dilation phenomena that appear to involve time only, such as the extended lifetime of fast-moving unstable particles, are in fact consequences of the variation of the relation between coordinate spatial location and absolute spatial location, meaning location in the natural moving system. With the speed of the objects occupying these locations. The Doppler effect, on the other hand, is independent of the spatial reference system. Okay, we're going to leave it there. Take over tomorrow. Thanks for tuning in. Have a great day.